In the following PV isotherm graph, what is the relationship between P and V in the limit that T is large? So if we look at this graph here, it's pressure on the vertical axis, volume on the horizontal axis. And then the isotherms correspond to these different curves. So we have one at a higher temperature, T2, another one at a lower temperature. And if you look at the labels here, there's liquid region and vapor region. So I think what's being described here is a phase change either from vapor to liquid or gas to liquid or the other way around, depending on what direction you're moving along this lower isotherm. So what this is saying is for this isotherm, if you're moving along that, we're talking about at a constant temperature, a phase change as a result of maybe pressure changes and then corresponding volume changes in one direction or the other. But what this is saying is that if you increase the temperature beyond some critical temperature, there will come to be a point where that phase change no longer happens. It turns out under this kind of curve right here, that's a forbidden region. So even though I've got this horizontal straight line, if you were, say, going from like condensation, gas to liquid at a fixed temperature, you would essentially jump from here to here instantaneously at the point that the phase change from gas to liquid took place. But now if you raise the temperature of that vapor and then applied pressure to it, if you're at a sufficiently high temperature, it never turns into a liquid. And that's a critical temperature. So there's a critical temperature for most substances beyond which that will occur. And so that's why up here it's labeled as an ideal gas, because it's going to always be kind of a vapor up there. In other words, it's going to obey the ideal gas law. So what we're actually being asked for here is it says, what is the relationship between P and V in the limit? That almost sounds like I'm running into calculus land a little bit there, so maybe I should explain that. In other words, basically I'm just saying you can ignore the in the limit part, but just when the temperature is large. Well, we just said when the temperature is large, that means we're up on this isotherm here. That means it's basically staying in ideal gas and no phase change is happening. And if we're working at a constant temperature, the relationship between P and V should be inversely related to each other. In other words, pressure should be proportional to 1 over volume. I believe that was Boyle's law, if I'm not mistaken. And so that's the answer I'm going to give here. Let's go ahead and check that with the slide. And it looks like that was the correct answer, although it doesn't clear up whether that was Boyle's law or one of the other ones. So hopefully I got that correct.